Welcome to the deep dive. Today we're really digging into something fascinating at Netflix. It's how they basically rebuilt their recommendation system.
Completely. And look, this wasn't just a small tweak. It was a huge strategic shift, a real big bet, as they call it, to make your viewing experience, well, truly personal. We'll unpack how they did it, why it's such a game changer, and, what it means for how you find stuff on Netflix, and maybe even beyond that.
Yeah, and a lot of what we're discussing today comes straight from the source, actually. It's based on a talk by Yesu Feng from Netflix. So we're getting a real insider's view on this
Right.
pretty cutting-edge work.
Right. So our goal here is to really understand how Netflix is taking this enormous, sprawling universe of content, movies, shows, games, you name it, and pulling it all together under one single unified system, all to help you find exactly what you'll love faster and hopefully easier. Okay, so let's pull back the curtain on this then. What was the specific pain point? What really forced Netflix to rethink everything? They were facing this massive challenge, right? With their old recommendation systems. I mean, just imagine trying to track every single thing you watch or play or even pause on, and then using all that data to suggest something new you'll actually like. It's incredibly complex, and their big problem, they called it diversity. This basically led to having tons of different specialized models. Just think about your own Netflix homepage for a second. You've got all those different rows, right? Rows for comedies, rows for action, new trending stuff, Netflix originals. That's one kind of diversity. Then there's the actual items. It's not just movies and TV anymore. Now you got games, live streaming, and they're planning to add even more different kinds of content. And on top of that, the different places you interact with Netflix, the main homepage, sure, but also the search page, the kids homepage, which is totally different. Even that mobile feed, the one that scrolls. Each of those interfaces, well, they used to need its own separate approach.
Exactly. And what's really interesting is how this diversity, this need for specialization, it led to a really fragmented system over time. You had all these specialized models popping up independently over the years. Some ranked videos, others ranked the rows themselves. Some focused on stuff you hadn't watched, others on things you were watching. They often had slightly different goals, but crucially, huge overlaps in what they were trying to do. And this meant tons of duplicated work, especially in what we call label engineering and feature engineering. That's basically the very manual process of deciding what data matters and how to classify everything for each separate model. Take your interaction history, for example. The basic facts, what you watched, when that's common data. But they ended up creating loads of slightly different features from that same data for all the different models, which, as you can imagine, made maintaining everything a nightmare. So yeah, this old way, it just wasn't scalable, not at all. Especially with Netflix adding more content types, more business use cases. It got really unwieldy. You couldn't just spin up a new model easily for every little thing. It was inefficient. It really slowed down their ability to innovate, to bring new experiences to you. There was a real lack of leverage, shared pieces weren't being used effectively. And yeah, their innovation speed took a hit. New models often had to be built practically from the ground up.
And just to put a pin in this, we're talking about maybe 4 years ago, right? Around the start of the pandemic or maybe mid-pandemic.
That's about right, yeah. That's when this situation really came to a head.
Okay, so they're wrestling with all this fragmentation, this complexity. What was the breakthrough question? What was the core idea behind this big bet?
Well, they fundamentally asked, can we actually centralize the learning of user representation? Like, can we create one single rich understanding of a user's tastes and behavior instead of having it scattered across dozens of models? And their answer was, a pretty bold yes. They decided to bet big on a foundation model, built using the transformer architecture, similar tech to what powers things like ChatGPT. And they had two key hypotheses driving this. First, they figured that by seriously scaling up semi-supervised learning, basically, training huge models on vast amounts of interaction data, they could significantly improve personalization. This is borrowing the scaling law idea from large language models, the idea that bigger models trained on more data just get better, applied to recommendations. Second, they hypothesized that if they could plug this one foundation model into all their different recommendation systems, they'd get massive leverage. They could improve all those downstream models, the ones actually putting recommendations on your screen all at once.
Wow, okay. That's a seriously ambitious goal. Centralizing something that was so spread out. How realistic was that? And how do you even start building a model like that? Let's talk about the data, the training. What did they learn from LLMs in the process?
Right. Well, building an autoregressive transformer for recommendations, it has similarities to LLMs, definitely, but also some really key differences. Let's start right at the beginning. Data cleaning and tokenization. How you decide to tokenize or represent user interactions has a huge impact on how well the model works. For an LLM, a token might just be a word or part of a word, simple enough. But for recommendations, each token is usually a whole event, a user interaction. And that event isn't just one thing, it's got many facets, many pieces of information packed into it.
So it's not just user watch movie X. It's more like user watch movie X on their TV Tuesday night for 45 minutes right after finishing show Y, and they give it a thumbs up. All that detail in one token.
Exactly, or at least you have to decide how much of that detail to capture. You need to think really carefully about how all those fields, the when, the where, the what of the interaction, feed into your tokenization strategy. There are always trade-offs, between how granular you get with the details and the context window, basically, how much past history the model can look at simultaneously. They found through lots of trial and error that they could adjust this tokenization for different needs. So once you've got these tokens, what's next? It's representing the event itself. Breaking down that when, where, what, when involves encoding the time. Where isn't just country. It's also the device, the specific part of the Netflix interface, the page, the row where it happened, and what covers the actual movie or show, the type of interaction, play, pause, add to list, how long it lasted, and any other related info. Then comes a really crucial layer, embedding and feature transformation. And here's a big difference from LLMs. For recommendations, you absolutely need to combine learning embeddings for item IDs, like a unique code for each movie, with semantic content information. Information about what the movie is actually about?
Why is that so important?
Because of the cold start problem. If you only learn embeddings based on user interactions, the model has no idea what to do with a brand new movie it's never seen anyone watch before. LLMs don't really have this issue because the vocabulary of language is relatively fixed, but recommendation systems constantly get new items. So to tackle this, they use semantic embeddings. These often come from graph models. Netflix actually has its own huge knowledge graph mapping out the entertainment world. This graph provides that extra semantic context, linking a new item to concepts the model already understands based on genre, actors, plot keywords, etc. Okay, then the core transformer layers process the sequence of embedded events. And the output, the hidden state from the transformer, that becomes the user representation. That's the goal, right? To learn a really good, stable representation of the user's long-term tastes. The challenge here is keeping it stable even as the user's history changes constantly, and figuring out the best way to combine information across time and across the different layers of the transformer. And finally, the objective function, what the model's actually trying to predict, it's much richer than in a typical LLM. An LLM might just predict the next word. But this recommendation model isn't just trying to predict what you'll interact with next. It might simultaneously predict how long you'll watch it, what device you'll use, maybe the genre or language of the next item, or even predict when your next viewing session might happen. This is multitask learning. It forces the model to build a much deeper, more holistic understanding of you.
Right, that makes sense. But given the scale difference, I mean, LLMs are massive. What were the biggest, maybe unexpected hurdles in applying that kind of scale to recommendations? Was it just about compute power, or were there fundamental blockers?
Well, the good news is the scaling law does seem to apply. They saw improvements as they scaled up. Over about 2.5 years, they went from models trained on, say, 10 million user profiles to models with around 1 billion parameters. So huge scale up with data scaled accordingly. However, they did hit a practical limit, or at least a pause point. Recommendation systems have way stricter latency requirements than many LLM applications. You click play, you expect recommendations now.
Can't wait 10 seconds for the page to load.
Exactly. You can't have long delays. So even if a bigger model could be slightly better, if it's too slow, it's unusable for real-time recommendations. This means they often have to use techniques like distillation training, a smaller, faster model to mimic the big one for the actual deployment. So there's a trade-off between raw quality potential and real-world speed. But they definitely borrowed some key tricks from the LM1 playbook that really helped. 3 stand out. First was top multi-token prediction. Instead of just predicting the single very next thing you might do, the model predicts a set of possibilities. This makes it less myopic, less focused on just the immediate next click, and more robust to the time lag between training and serving. More importantly, it pushes the model towards optimizing for long-term user satisfaction, not just the next interaction. And they saw significant metric lists from this.
Okay, so thinking further ahead.
Right. Second was using multi-layer representation for the user profile. Borrowing techniques like layer-wise supervision and aggregating outputs from multiple layers helps create a richer, more stable understanding of the user over time. Again, ideas refined in LLM research. And third was long context window handling. Think about how much history the model can remember. Traditionally, maybe it only looked at your last few interactions. Now, using techniques like sliding windows, sparse attention, and training progressively on longer sequences, they can feed the model much, much longer interaction histories.
Like hundreds of interactions instead of just a handful.
Potentially, yeah. This allows for much more nuanced predictions based on a deeper understanding of your viewing patterns over time, capturing more information efficiently.
Okay, that's a major overhaul under the hood. So how does this foundation model, the FM, actually change things for us, the users? What does it look like on our screens?
Well, think about the before. Loads of separate models, separate data pipelines, separate feature sets, all trying to do similar jobs for different parts of the interface. Now, with the FM, a lot of that is consolidated, especially the layers responsible for understanding users and content. The models that actually serve the recommendations on different pages, they become much thinner, much simpler, because they're building on top of the powerful representations already learned by the central FM instead of having to learn everything themselves from scratch. And there are basically three main ways these downstream applications use the FM. One, they can literally integrate the FM as a pre-trained component, a subgraph, directly into their own neural network. It replaces parts of their old model.
Like plugging in a super smart brain module.
Kind of, yeah, including using the FM's content embeddings directly. Second, the FM can push out its learned embeddings for users, for movies, for genres, whatever, into a central storage place. And this is huge because now those rich embeddings aren't just for personalization. Other teams, like data scientists or people analytics, can access and use them for all sorts of insights, much wider use. And third, applications can take the FM or parts of it and then fine-tune or distill it for their specific needs. This is particularly useful for applications that need to be extremely fast, like those serving recommendations in real time with very tight latency budgets.
Okay, the complexity is mind-boggling. But as you said, the proof's in the pudding. Did this massive big bet actually work? What results did they see?
Oh yeah, it definitely seems to have paid off. They've tracked the wins over the last year and a half or so. They showed this chart with a blue bar representing the number of applications adopting the FM, which steadily increased. And alongside it, a green bar showing the cumulative positive impact from A/B tests, real improvements in metrics like engagement or retention. That bar went up significantly too.
So better recommendations, essentially.
Better recommendations, more efficient system. It validated their hypotheses. It is scalable, they saw quality improve with scale, they consolidated their infrastructure, and it's easier to build new recommendation features now. It does provide high leverage, thanks to that centralized learning. One improvement benefits many applications, and it has increased their innovation velocity. New teams can launch features faster by fine-tuning the existing FM instead of starting from zero.
That's pretty impressive, a real strategic win. So looking forward, what's next? Where do they take this foundation model now?
Well, they're pushing in a few key directions. One is continuing to build universal representations for heterogeneous entities. As Netflix keeps adding diverse content games, live events, who knows what's next? They want the model to understand it all using consistent semantic IVs. A second area is generative retrieval for collection recommendation. This is really interesting. Instead of just picking individual items, the model could learn to generate entire collections or rows of recommendations on the fly. This could make it easier to handle things like business rules, diversity requirements, or maybe even thematic coherence within the generated collection itself.
So generating a whole movies featuring strong female leads row, for instance.
Exactly. Or something even more nuanced, generated dynamically. And third, they're exploring faster adaptation using prompt tuning. This is another idea borrowed heavily from LLMs. The idea is to train small, soft tokens or prompts that you can swap in at inference time to nudge the main FM to behave differently for specific situations or user segments without retraining the whole giant model. More agility. And just touching on some insights from the Q&A part of the talk, they confirmed this trend isn't just about recommendations. They see potential in using this kind of user understanding beyond just suggesting content, maybe even capturing taste from interactions off the Netflix platform eventually. That's a broader goal. They also confirmed heavy use of graph models, especially for that knowledge graph we mentioned, which is critical for content understanding and tackling the cold start problem. And yes, reinforcement learning, RL, is also in the mix. They use it particularly where rewards are sparse, like getting you to start a new series to help guide processes like that collection generation we talked about.
What about using the actual video data itself, like frame by frame?
Apparently not heavily for the recommendation embeddings yet, but they acknowledged it's definitely a future trend their content analysis groups are looking into, using the visual and audio signals directly.
Wow. It's really quite a journey, isn't it? From that complex, kind of messy, fragmented system they had just a few years ago to this single, unified, incredibly powerful foundation model. It's scalable. It gives them leverage. It sounds like a fundamental shift. And it's not just about Netflix getting incrementally better. It feels like they've built an adaptable intelligence engine, something that can learn from whatever new content type they dream up next, making sure you always find things you'll enjoy, no matter how much Netflix changes. That feels like the real win here.
Absolutely. And the bottom line for you, the listener, and for millions of others, is hopefully a faster, smarter, more intuitive way to discover content you love, even as the sea of choices just keeps getting bigger.
It really makes you think, though. If one big model can get this good at understanding and predicting your viewing habits across movies, shows, games, what other parts of our digital lives, or maybe even bigger societal patterns, could we understand better if we had similar comprehensive models representing user behavior or preferences? Something to chew on.
Thanks for joining us on this deep dive today.